This video series is not going to focus on the launch pad itself. There's several little things that can happen on the launch pad that can cause some problems during launch. We want to try to understand what these problems are and how we can correct for them. Keeping with the general principle of this channel is to do some model rocket engineering. Let's take a look at some of the problems, what we can do to fix them, and what their effect is going to be on our flight quality, and really if the flight's going to be safe or whether it's going to be a good flight or not. So now we're going to take a look at some of the launch pad engineering problems. And what's interesting about the launch pad that I find is that it's like, well, I can design it to do anything that I want. When I started doing that, I started realizing that there can be some serious problems if it's not done correctly. So let's take a look at how we can get a high quality launch pad. I would like to frame all the information on launch pads with a couple of diagrams and definitions. If we take a look at a launch pad, I collectively call the launch pad comprised of really two logical sections. We got the launch base, which will establish a solid connection on the ground. And this can be done in many forms. There's many different ways to do this. The second part is really the part that holds the rocket. And I'm going to call this the launch platter. Now, for various reasons, which you'll see in later videos, I make them out of dinner platters, out of stainless steel. So I just simply call them the launch platters. This is typically comprised of a blast deflector and the launch rod. The rocket slides over this, and the launch lug will allow it to be guided up the launch rod. And this works quite well on virtually all rockets that are relatively small. So we see this particular configuration being used for 1/8 inch rods, 3/16 and 1/4 inch rods. So this is really a very nice type of system that most beginners are going to have when they first start out in model rocketry. It's very expensive and it's easy to put together. It does have some limitations though, and this is something we want to start talking about. The fact that this works extremely well for the smaller rockets, but as you start making them a little bit bigger, you can end up with some quirky things happening on your launch pad. And I discovered some of these by watching videos, other people's launches, my own launches in slow motion and other things. And I corrected all these different details to make a more reliable launch pad. I'll bring up the fact there's also what's called a rail. This is what's called a 1010 rail, typically used in model rocketry. That's 1 inch, 1.0 by 1.0 inches. It's a square rail, which is extremely rigid. And that's typically used for the very large rockets when you start getting into the very high, medium, and high power type of rockets. For most of what we're going to be talking about, I'm a low power person. I do low and mid power. I typically run all the way up to maybe the E engines, and that's about the limit of the type of power that I use. And these work very, very comfortably on the launch pads where we have a 1/8, 3/16 or 1/4 inch rod. And I do not currently use the 1010 rails at this particular point in time. So this is your typical launch configuration. And what I'd like to do is to go through some of the places where we can start ending up with some problems. Okay, I'd like to take a look at something that can go wrong with the launch base itself. And I'm going to call this bounce. I don't know if it has an official name, but it does have a particular problem that can occur. And I did see this on some videos in slow motion that some people were showing that they saw this happen and that it causes some particular problems on the launch. So really what's happening is that if we take a look at the rocket on the launch pad, I'm going to start out by saying, well, we've got this launch base down here, but it's going to have these legs which extend on it, and there's going to be a small part in the middle that the rocket platter system is attached to. Now, what's going to happen is that when the rocket engine ignites, that blast is going to push down against the blast deflector. As you can see in this particular diagram, it's going to push the center downward. And I actually bent these out a little bit to show that the launch pad itself is actually going to be compressed downward. It's going to snap back upward. And all this happens in about 1/10 of a second, but it's enough that it actually bounces the launch rod. So the rocket suddenly will find itself misaligned as it takes off, and it's going to potentially do some crazy things. It might go off to the side, or if the rod is whipping a little bit, it's just going to get caught. It's going to squeeze the launch lug, and you're just not going to get a lot of acceleration. So sometimes I see these launch pads, and they have these really large rocks on them, and they don't really explain most of the time what's going on, except I did find one video that talked about it very specifically. They said it was to prevent this problem. So the stabilization weights are added to the bottom of the launch pad legs to hold the launch pad in place to prevent it from bouncing downward when the rocket ignites. So it's a very unusual problem. You could generally only see it under a high-speed video. However, it does make the launch rod whip very, very quickly. So that quick jerk on the launch rod can jolt the rocket back and forth a little bit, just enough to cause it to go off to a crazy, unpredictable direction because the launch pad itself has been bounced around very, very quickly. So this is, again, what I call the launch base bounce. It's a problem that is very easy to correct. Now, I later have built my own custom launch pads, and I have a very strong support in the exact center underneath the launch rod itself. So depending on how you build your launch pad, this may not happen. But if you look through a lot of videos on YouTube and other areas, you'll see that many of them use this type of tripod type of structure, where you've got the launch base and then you've got these legs extending from it. Matter of fact, some launch pads actually use an actual camera tripod, and they just attach a blast deflector to it. So again, some of these under slow motion analysis will probably exhibit this bouncing effect where the pad will drop down and then snap up, and then the rocket itself is going to find itself jiggling on the rod because of that quick snap. It's like a tight rope, and snapping the end of it, it's going to make these bounces go back and forth, and it's going to whip the rod. Again, it happens very, very quickly, but it happens enough that it does add some level of unpredictability to the actual launch. So again, the solution that I have seen are these weights here and here. Usually they were big rocks. And the solution I use, and we're going to see in future designs of launch pads, is right here in the center. I'm just going to have a very, very strong support to make sure that the weight of the launch platter and the base are directly supported in the middle. I would like to talk about another problem that can occur, and this is called launch rod whip. Now this is where the launch rod on top, it'll simply whip back and forth. And in doing so, it's hard to get a stable launch if you're really not sure what direction the launch rod is pointing. So what causes this, and what can we do about it? Well, the most typical cause for this is that the wind is just simply blowing against the launch rod, and that's making it whip back and forth. And as that happens, you have to try to get a good launch with the launch rod moving back and forth. And that's really not that easy to do. Now, this is going to occur a little bit more often when we're using a thin and a longer rod. The typical launch rod for the small lower power rockets is the Estes launch rod, which I believe is 30 inches. So it's fairly short. However, it works quite well for the smaller rockets. So the rockets are fairly small. The launch rod is small. It's reasonably stiff, and there's really no problem. However, if you start using a longer rod, and some rockets do say you should use a longer rod because the rocket may be fairly tall. Like if you have a big Bertha, which maybe it's almost 2 feet, I believe, that's going to be quite a distance up your launch pad, and you definitely want to be aware that the rod may be longer so you can have a better launch. But again, the longer rod means you've got a chance of more whipping that can take place. So this is yet another problem that can occur, and there's several solutions to this, which I'm going to be looking at when I show the actual builds that I have done. But it's not obvious how to really keep this rod stationary and how to keep it still. So that could be it's a real challenge, and it can mess up your launches quite a bit. The last problem I want to take a look at, I'm just going to call this thrust misalignment. Now, again, I don't know if it has a real name to it, but it's a problem that will happen, and it happens. When it happens, it can cause a lot of problems. Well, let's take a look at the rocket on the launch pad. I moved the launch lug here to the center so it's much more visible. But you can see if the launch lug is tipped a little bit, the rocket could be tipped. And when the thrust comes out the bottom, it's going to really try rotating the rocket around in a circle. And that's going to cause a problem. So there's several problems that can result from this. And first of all, I can say that this can happen from two different reasons. The launch lug itself may just simply be misaligned on the rocket body. Sometimes just a little bit, and it can cause the rocket to be tipped a little bit to the side. Second thing could be is if the rocket itself is just a little bit heavy on the nose. And this can happen if you're holding like an altimeter up here, or maybe a camera, or even if you've got a larger streamer. The weight of the nose itself could pull the rocket off to the side a little bit back and forth. And there's a little bit of play in the launch lug that may be just enough to tip your rocket to the side. So when the rocket ignites, the engine ignites, it's going to basically take the bottom of the rocket, try twisting it around in a circle, and we could end up in some serious trouble. The most obvious thing that happens is that the launch lug itself might just simply tear right off because you're twisting the launch lug directly at the launch time. Now, there's a lot of comments on how to really fix this. One of them is to just use a much longer launch lug, and yeah, that'll work. And another is to make sure that you use some heavier duty glue. And I myself, I use polymer glue, so it's attached quite well. But still, the stress on the launch lug is extremely significant right at the time when the engine ignites. And if this is not a smooth transition going upward, it's just going to cause some issues. I had one issue where the rocket tipped to the side a little bit, and if you have the lug tipped to the side, it's just simply going to pinch the launch rod, and it just slid up the rod, and the engine burned out at the top of the rod, and the rocket basically got stuck. I've seen this happen to other people too. The rocket will go up the launch rod, maybe halfway, and then stop. And they go, well, gee, what happened? The usual thought is that, well, there must be something sticky on the launch rod. I usually don't think that's really the case, because if there's something sticky in the launch rod, probably when you put the rocket on the launch rod, you would have noticed it. So the most probable cause is the rocket tipping a little bit off to the side, and as it went up, the launch rod, the tipped launch lug just simply started pinching the rail, and it just burned out the engine before it even got off the launch pad. So there's a couple of things that you can do to fix this. One thing that I like doing is I like using two launch lugs. Very few designs use two launch lugs, but I find that two launch lugs where the first lug is down here near the bottom and the second launch lug is near the top, that gives you a much better chance of keeping the rocket exactly straight. In the case where I use a camera on the side, that's going to put a lot of weight on the side and cause it to tip, so that extra launch lug up to the top keeps that nose perfectly aligned on the launch rod itself. So this will be a better solution for almost any rocket that's over, I would say, about a foot long. So if you got rockets that are more than 12 inches long, I suggest using two launch lugs. Sometimes I just cut the launch lug in half, put the part on the bottom and part on the top. This is also good because as the rocket is going up, the bottom of the rocket still has a little bit more time being held going up straight to get some additional stabilization as it gains some speed. So again, you might want to think about going to using two launch lugs, one at the recommended size, another one fairly small on the top, maybe only a half-inch long, to help stabilize the rocket on the actual rod. When you think about this, this is also grabbing the rod now in two different places, so it tends to hold the launch rod a lot more stable and reduces the whipping effect. So it's good to use two launch lugs. It'll cut back on any potential misalignment issues. It'll also cut back on the whipping issues. So again, we get some good solutions for our entire launch system. So coming up in this series, I would like to show how I actually built several custom launch systems. The launch systems come in two different types of components. There's the base, and I have different bases depending on where I'm flying. Some places have nice level grassy fields, very even, in which case I can use one type of launch base. There's another type of launch facility that we use where it's a farmer's field. So it's basically plowed, there's dirt, bumps, stuff laying all over. It's just really, really hard. There's no such thing as level in a plowed field. So in this case I use a different type of base. So I use these different types of bases, and they actually have an interchangeable connector on it. The interchangeable connector allows me to connect various launch platters, as I call them. I call them launch platters because they're made out of stainless steel dinner platters. So the blast deflector rather than being the typical little 4-inch blast deflector, I use a 12-inch stainless steel metal platter, which I think is much more effective. So using this modular design, everything can be put together quite easily, very quickly, and I can set up my launch system for almost any type of field that I'm going to be flying in. So that's going to be coming up in the remainder of this series, and we're going to be solving all these problems as we go along. So let's go ahead and enjoy building a launch pad system. Again, I thought it was really fun to say, well, I'd like it to look like this, and I want it to be modular, so I can hook this together. And be creative. Do whatever you want that you want to build, but you have to think about some of these problems that are going to occur. And this is where I've seen some of these problems inadequately solved in some of the other videos. So I'd like to present some very good solutions to how to make a good, stable launch pad system.